everyone. I'm Til. I work at KDAB, where for the last 20 years we've helped people with their software projects, mostly in C++. So my beard is gray because I've seen and written way more crappy C++ code than any man should ever do. This is Florian, who can tell you why his beard is gray himself.
It becomes gray since I'm 20. Hi, I'm Florian. I'm part of Systems, one of the co-founders. I'm also, my biggest open source contribution always is actually fixing typos that I see in keynote slides. So the code had one. So let's go.
Yep, so we have decided to frame this as the Aloha approach to migration from C++ to Rust. Meaning that we want to go about it with love, affection, compassion, and mercy. So let's see how that goes. So I used to be a rock musician, an electric guitar player, which was awesome because you could make a lot of noise and it was a lot of fun. It's great at weddings. People sort of expect that to be there, and you can make people happy, but it does come with a lot of complexity. This nicely AI-generated image actually has a 8 or 9 string guitar-ish. Actually, all of that is crap, but it sort of vaguely looks sort of believable anyway, which is fun. And then some years ago, I discovered the ukulele, which is much simpler. It's much harder to mess it up. You just kind of pick it up. It's really hard to get something bad sounding out of an ukulele. How many of you have tried an ukulele ever? It's a lot of fun. It gives you joy, right? You pick it up. It's nice. It's pleasant. So to me, Rust is a little bit like that. It's much harder to mess up mostly, and it brings me joy after too many years of C++. There's an element of Aloha there, right? But let's face it, wedding bands will have electric guitars for a while still. I don't think there is a world where we will have ukulele-only live music or recorded music, as much as I would like to see that. So the reality of it is we sort of have to make these two worlds work together. We will try and explain how we do it, how we have seen it done in practice, and maybe a little bit how you shouldn't do it. We will go from the very lowest level to the very highest level. So we start out basically with individual lines of code, so C++, C code, and Rust code. And I'll hand it over to Florian for this.
So basically what we're talking about always when we start these kinds of endeavors, the lingua franca of languages to talk with each other is actually the C FFI, like for any language. And it's kind of the lowest common denominator, and there's some problems about it. Not like in general it works, but it is the basic C calling conventions and extern symbols. It does not add anything on top of that. So it boils you down to anything in the end becomes C. There's this great blog post by someone called Gankra at some point where they said C has transcended being a language. It's even the part how other languages communicate to each other. And it works very well for small inline bits of foreign language interchange where I'm in tight control of what both sides do. And the other thing that people are often missing about the C ABI, it is less a standard. It is so pervasive that people consider it a standard, but it actually isn't. It is something that each of the platform vendors say, this is how C code interacts on my platform. So it's operating specific, it's architecture specific. And it's a bit of a mess, but more in the sense of it is so old and a lot of problems were fixed along the way, and it carries all of that knowledge in it. And the best way to interact on that level with Rust is actually there's two tools called cbindgen and bindgen that operate on the two different sides. The one is more for I have a Rust code base and I want to expose it to C, and the other way around. Both of which come out of the Rust project or out of the circle of the Rust project. cbindgen is maintained by Mozilla. The actual bindgen tool is maintained by the Rust project. We at Systems have been working on that for a while, our co-maintainers of that. And they generally work very well, but they're pretty straightforward. They have no pattern awareness, I would say, of how does the program on the one side work, or the library, how does the program on the other side work. And this is, in general, the problem that gives rise to other approaches that, for example, Til will introduce. And particularly, we'll start with bidirectional ones, where we consider, hey, both sides are kind of on, like we'd like to expose from one side to the other and vice versa.
Yep, so it's usually more productive to have some awareness of what each side wants to do, what sort of paradigms there are, what API patterns and so on. So one approach to that is something called Krubit, which comes out of Google, and it's basically just Google's internal approach to solving this problem. They are very open about the fact that it's basically unusable for anybody outside Google. So this is open source in the sense that you can freely look at the code for inspiration, which is nice of them. But it is effectively not very usable because it basically assumes Google-specific build infrastructure and their particular monorepo layouts and so on. So most of you probably will not be who's using Google's build system. Good for you. Do any of you work for Google? No. So again, it's a fine effort, and it does present some best practices here because it's open source, but it's not practically useful for the vast majority of people outside of Google, at least. The more generic or general approach, and that is the one that we like and use, we as in KDAB, when we help people integrate Rust into their C++ code bases, is a crate called CXX, which effectively, instead of having a one-directional binding approach, it basically defines a bridge between the two. So you're basically saying, this is the interface that my Rust and my C++ and C should have, and then it generates code on both sides, which has two very important benefits. First of all, the Rust code looks like Rust and feels native and nicely usable from an API point of view, and so does the C++ code. But in my mind, more importantly, it actually produces safe bindings, because that's the whole point of using Rust in the first place. So if you have something like bindgen, it will generally produce unsafe Rust code, which is sort of moots the point, right? Why would you use Rust, unsafe Rust, when you could use more or less the same code just from C or C++? So this is, I think, one of the core benefits of something like CXX, because you end up mostly with the unsafe stuff neatly contained in a generated piece of code, which is much preferable to having the unsafe code in the code that you interact with and that you write yourself, because it is much less likely to be wrong, right, if it comes out of a generator. On top of this, we've built something called CXX Qt, which, I don't know, you're familiar with Qt? Yeah? Yes? No? So, very prevalently used UI library in Qt, in C++ land. So a lot of people have a lot of C++ code, and a lot of that code has a Qt HMI on top of it. So one of the things that we see a lot of people do is try and integrate some Rust for some aspect of the functionality into these applications. And so it's really nice to have something specifically for Qt that allows you to interact with the types and sort of have a natural feeling interaction between the Qt, let's say the property system, the single slot mechanisms, and the Rust land. So you can more or less freely decide whether you want to move something to the Rust side or stay on the C++ side. There's a bunch of tooling that comes with that to integrate CMake and Cargo. And you can do, for those of you who do know Qt, you can do QObject subclasses in Rust, which I think is pretty cool. And that's serves a practical need that a lot of people have with these sort of hybrid code bases. Yeah, there's some more unidirectional options for completeness.
So if the whole problem of we want to integrate in all directions is not yours, for example, you want a shared library between all kinds of smartphone applications and a web browser or something like that, there's always the ability to just say, okay, I want to integrate Rust into another host program and take the unidirectional route, just say, this is my interface, and then generate it to different languages. That's actually a surprisingly common way. There's two large tools around this. The first one more experimental than the other one. The first is Diplomat. It is clearly saying it is for foreign code that wishes to call into a Rust library, not vice versa, and it directly highlights otherwise you should use CXX. And the second one is Unify RS, which is quite common. Mozilla deploys it in lots parts of Firefox. Particularly one of the maintainers of Unify is here, Jan Erik. So if you have any questions about it, It's a very useful library. It's a little bit of the odd one out because I'm breaking the rule of this talk here. It doesn't speak C++ yet. Computer contributions welcome. And there's a very good comparison between both of them written by Unify. Just want to highlight the option, if bidirectional is not your problem, there's ways to serve you, and that probably makes the issue much easier. Build systems.
Build systems. So we're going up a little bit the stack. So now we've integrated individual lines of code. Next step is to look at, okay, I've got some Rust libraries maybe and some C++ stuff, and now how do I bring that together? Which gets us into the wonderful world of build systems. Everybody loves a build system, right? Everybody has written a build system probably at some point in their life, and then discarded it because they realized that it's not something they want to spend their life on. In Rust, it's easy because there's really only cargo. That's what everybody uses. In C++ land, there are, of course, multiple, like with everything in C++. But the most commonly used, at least in our practical experience, is CMake these days. So you basically have to decide, do I want to drive this from CMake or do I want to drive it from cargo, right? So do I consider myself a C++ application with some Rust in it, or a Rust application with some C++ in it? And that's sort of, one day you will wake up and you will go jump over that creek and maybe look back or maybe jump back, I don't know, but there's a decision point somewhere along the line in your project how you want to do this. If you're driving it from CMake, so let's say you're more on the C++ side still, there is something called corrosion, which you should definitely check out, because corrosion basically integrates Rust with CMake in a rather nice way. It's under development, but it already does the job pretty much just fine for the majority of use cases. So that's sort of the standard way of doing it from CMake. If you're coming from cargo, so this is now the other way around, you're now I should jump on this side of the thing, and if you're coming from Rust and you're trying to integrate C and C++ code into your otherwise cargo build thing, there are two crates. The one that I would say we have a slight preference for is called CXX Build. It's part of the CXX project. That's probably why we tend to use it, because we're mostly using CXX. But there's also something called just CC, which is effectively a way of building C, C++ code programmatically from cargo. Little special thing here is that if you are in need of compiling assembly or CUDA, which stuff you load onto the graphics card to execute there, this might actually be a good way of doing it for this specific sort of niche use case, if that's your thing. So now we have a mixed code base, most probably with some Rust and some C++. But one of the architectural ways to do integration that actually happens very, very frequently in practice is to introduce process boundaries. So basically to isolate one of the two in a separate process or in multiple separate processes, at which point you are in the wonderful world of inter-process communication. And as was hinted at previously in the previous talk, there are many, many ways of doing that. There are ways of doing it through files, through serialization of some in-memory structures into various formats, through pub-sub broker-style communication, or through buses, through sockets, and using things like protobuf or flat buffers. So there's a lot of different solutions for different use cases. So this is a case of pick the one that most closely matches your actual domain problem that you're trying to solve. So whether you're focused on latency, or you're focused on throughput, or you need both, or whether it's across network boundaries or whatnot. So pick one, effectively. And the good news is that you can find interface libraries to these things for both C++ and Rust pretty much for everything. We've listed a few here just to save you some Googling. So basically, you pick a transport mechanism or a serialization format, and then you have a library that does it in C++, and you have a library that does it in Rust, and the two talk and exchange data, and you can do that across a process boundary or even the network boundary, or a device process boundary. One interesting sort of hack, because the problem when you have serialization code in two different languages on two sides of the connection is that serialization code is usually going to be different, right? Because you have an implementation in C++ and an implementation in Rust. And so you have twice the bugs, you have the interoperability issues of, is the thing going to serialize exactly as I expected on the other side, and so on. So one hack that you might consider is to actually use the same serialization code on both sides, and then wrapping that serialization code in the other language, right? So let's say you want to serialize and deserialize in Rust using SERDI, which makes sense because that's really good for that. You could then expose whatever you have serialized with Rust to a C++ API on the other side and then talk to that from your C++ application, thereby sharing the serialization, deserialization code, which tends to be safer. And actually, this is the kind of thing where Rust, again, has benefits over C++. You know, you're potentially passing externally incoming content, so from a safety and security point of view, you might want to use Rust for that. So the unintuitive approach is to not use a C++ implementation of your protocol, but a Rust one, and then wrap it in a C++ wrapper, basically, and use that from your application. You do have to be careful with possible duplication, copying, performance issues that come with that, because, of course, you might have to, on that wrapper from Rust to C++, you might not get away with doing it zero copy in all cases. So that's possibly a concern. But in a lot of cases, this stuff is not really critical in terms of the, let's say, memory pressure or something like that. So the copying around might be something you can easily live with for the benefits that this gives you. Yeah, there's ways to actually automatically rewrite. If you do end up saying, well, I'm going to throw away my C and C++, at least for this specific thing, for this process, for this library, and I do want to turn that into Rust code, there is ways and approaches to actually doing that in a semi-automatic way, which Florian will talk about a little bit.
So there's one old one and two new approaches, pretty new actually, coming out in the recent month. The big old one is C2 Rust, a program that very well translates any C into mostly unsafe Rust. And there's two new ones, CPP Rust Assisted Migration and Rust with Object-Oriented Features. Particularly the latter one is interested because it tries to replicate the bare minimum of what you need for integrating with an object-oriented language on the Rust side. They're interesting because we see and know about those being used in deployment, so they're not playthings. Definitely C2 Rust is not a plaything. However, they are assisting you on a first step doing the process. And particularly the most important thing to warn you about here is any kind of bugs and soundness bugs that your C has will be transferred to Rust, and you need to figure them out there. Which does not mean that they're in any way they're a huge helper, because they can do a huge chunk of the initial work. But they are used for complete migrations where then humans go and take this code that is generated and rewrite it into idiomatic Rust. I know that C2 Rust is currently at the level where they're actually trying to build assists for that and start guiding that process more. But just be aware of that, like probably the idea of we just take C code and we transfer it to Rust just by the click of a button is couple of years, if not decades out.
Yeah, so the roof thing I'm personally really interested in. It was actually released May 15th. So it just barely made it into these slides, which of course we prepared months ago. So I really look forward to checking that out. It does seem quite interesting. I'm not quite sure what the object-oriented features are. I'm guessing some sort of runtime polymorphism thing. We'll get a little bit later to that, but that's one of the biggest challenges with all of this is sort of the mismatch in paradigms, right? The object orientation versus the Rust approach. So getting those things to actually align on a conceptual level, that's really the challenge much more than getting the syntactical conversions going. So. Yeah, so the next few slides are actually based on experience from migration broadly, because as a company we've done a ton of migrations from various technologies to other technologies, and we've learned some things about how to do that systematically in basic principle, and it applies also here. Generally, a good idea is to just refactor before you start migrating, right? So try to introduce library boundaries, process boundaries, layers, some sort of structure that allows you to get an idea of what is independent in your application or your project and what is not. So you're more aware and it's more explicit where the dependencies are, where you could break things. When you touch this thing is going to fall. So having these things as explicit as possible is always helpful, and it is in this case also. And then you can pick an individual bit. You can pick a file, you can pick a library, you can pick a process, and then transfer that with the tools that we have just introduced. So we've tried to, can you clicky? Yeah, we've tried to come up with two recipes of the manual way, if you will. When the rest is Rust. So now we're basically almost completely Rust, and we have these few things that are still C and C++, and we want to bring them over. The suggested way that we think is sensible is to say, first of all, you create a sort of an API surface for the thing that you want to bring over. You wrap that, the C++ that you have in that API, so now you can call it from the rest of your system. You port the rest of your system to that API. You cover it in unit tests as much as you possibly and humanly can, which in the real world often means not very much, but ideally you spend some time on that, because all engineering managers really like having people spend time on covering things with unit tests, in my experience. You then try to port the thing that you have now encapsulated and hidden behind a nice API and unit tested the hell out of into idiomatic Rust, right, with the tests that you have. You add more tests as you go along because new bugs will appear, and there's a new code base now, so that needs testing. And then you switch the API from the previous implementation to the Rust implementation. Ideally, your tests all passed, and because the tests were comprehensive, you are now fairly certain that you didn't break anything. This is the ideal scenario. Obviously, you will break things, things will fall apart, you will have to find, the bugs and go back, but this is sort of the tactics that we think work best. And if you're doing it from C++, so basically you are within a generally C++ application, and now you want to take some part of that and bring it over to Rust. The big challenge here is, as I mentioned already, you need to sort of break the object-oriented API reliance at that point, right? You have to find a way to express what that module, that functionality is doing in a non-object-oriented way, so that you can provide a non-object-oriented API to it, because otherwise you'll have a really, really hard time trying to do an implementation of that in Rust, right? Because Rust just doesn't provide the facilities for this sort of API surface. But otherwise, the process is more or less the same. Again, at the end you switch, and then hopefully everything is much better than it was before, or maybe not. But the basic approach, I think, is sound. So what's the problem with all of this? First of all, as I mentioned, incompatible API styles. Like, you can't just shoehorn an object-oriented system into a non-object-oriented API. Or at least it's not trivial, right? You have to make decisions about, okay, where do I stop the polymorphism, and what is my functional interface sort of to this thing? Can I hide it maybe behind a services API that does somehow model the object orientation in some way? So maybe that's easier than trying to provide a Rust APIs to put it behind a service, because there you have more options in terms of objects and thinking in hierarchies of objects. But that's really the tricky part, right? That's where you have to do the work in terms of conceptually understanding how your system is put together. In terms of actually going to Rust, and this is my C++ bias speaking here, clearly, Florian can whack me over the head. My perception, our perception is that Crates.io is awesome, and there's a really, really nice large ecosystem there, but there is a proliferation of what I would call 80% ports. So basically somebody thought, oh, we need a CAN implementation, or we need an MQTT implementation or some such, and then they go and do the 80% of making that available that are fairly easy to do, and then they hit the, oh shit, I don't know how to do this part, which is, as we all know, the hard part, right? Pareto tells us that that's where you're going to spend the rest of your life, and then they sort of move on to the next project because they lost interest in it. And the problem is that if you're going about a project plan and you're looking at, okay, MQTT, fine. Actually, I'm picking on MQTT. I don't know the quality of the MQTT RS. I don't want to pick on them specifically, but just as an example. You pick some technology, you look at Crates.io, oh, there is a Rust crate for it, awesome, we can go ahead and do that. And then you do your port and you realize it's missing the last 5% or 10% or 20% that are the really nasty parts. And so you end up spending a lot of time doing the bits that nobody else wanted to do. Ideally, you're not the only one doing that, but there is a lot of crates that are in this sort of state where it's not quite done the way you would expect it to be done. That's going to hopefully solve itself over time, but right now it's something to absolutely be aware of. And we can only encourage you to do some extra due diligence when you're picking crates and assuming that they will be functionally complete or quality-wise up to your expectations. There are a lot of crates maintained by one person, which is not a buzz factor that most companies are comfortable with. So expect to maintain all of your hundreds of dependencies yourself at any point, right? Which, again, is one of those cost things that, particularly when you're enthusiastic about Rust and you're going to your manager saying, oh, it's no problem, there's this huge ecosystem, we'll use all these libraries and everything will be fine. You should point out to your manager that in the worst case, you will have to maintain all of those dependencies yourself until the end of time. That's I think the only professional way to look at this. Hopefully you'll get away without doing that bit. There is a problem with version mismatches, so some crates depend on certain versions of other crates, and you can quickly get yourself into a version and dependency hell sort of thing, where you need a version of some crate that has that, but the dependency actually needs another one, and then all of a sudden you're chasing, I need unstable, top of the Git repo of everything, because that's the only way to resolve the dependency. So that's, again, improving, but it's still a concern for a lot of stuff. Particularly when we're getting into niches, low-level embedded stuff. The mainline stuff is fine, right, by and large. Yeah, and again, conceptually, it's really hard to reconcile the style in which memory management is done in C++ and Rust. Believe it or not, there is actually memory management being done in C++. We don't just allocate and pray, unlike, but the concepts of how you do that, owning pointers, objects that wrap ownership, and so on, are just different from the borrow checker, right? So you have to sort of wrap your head around where do you have the boundary between those concepts and how do they interact? And again, that's more of an architectural, conceptual thing than a code level, let's convert this to Rust type of thing. Yeah, and again, Florian can comment on this, but we experience the overall foundation of, let's say, the ecosystem and the libraries and technologies available there to be still more rapidly evolving than is comfortable for a lot of people in industrial settings, meaning they'd rather freeze the version and then never touch it again, because that's how they roll. And you just can't do that right now, right? You're going to have to be updating tons of stuff all the time. And if that's not something you're comfortable with, then that's something you have to mitigate in your project planning. Is that fair to say?
Oh, well. It's been a lot. First of all, I have absolutely no problem with that statement of proliferation of 80% ports, because I'm definitely an author of some of them. And it's my 10-year effort. Like since I'm a Rustacean, I have written a library that was very early trying out how C FFI works within Rust. And at that time, I had absolutely zero understanding on how that works. And I did the mistake of putting that on GitHub, and some people took the mistake of not looking, as this is just one person who just tries out C FFI and have deployed that into production systems. And since this day, I'm trying to convince them to move off this crate because I don't want to maintain it. Just plain do a rewrite. It's not even big. So please, if you're choosing your software, and if you're choosing your dependencies, do actually look out for these factors. Do even write that person an email. Like, are you intending to maintain this in the future, or did you just implement MQTT for fun because you wanted to figure out how MQTT works? That's an important decision to independent of Rust or not. That leads to a lot of problems down the line. The thing with the unstable foundations, I think there's a bit of a tension point. Software needs to move faster. Nowadays, we have security bugs to fix. We have new problems to tackle. On the other hand, I do totally understand that the foundational parts maybe should be more stable. And indeed, I wrote a post in 2015 to the Rust mailing list where I said we need a 1.0 HTTP crate. Like something as simple as HTTP needs to be stable for an ecosystem to build around it. And I wish we put more things of that kind of stuff into 1.0. There's still the option of making a better implementation later. Just call it a different name or make it a 2.0. That version number exists for a reason. And that brings me to the last point. I've been lead of the community team. No talk by me without a community slide. One of the things that I experienced, particularly around Rust and C++, is a little bit of, there's a mismatch in values, and I just want to observe that. That's completely okay, and it even shows on our websites. If you go to, well, Rust has an official website, and it starts with a language empowering everyone to build reliable and efficient software. So before we're talking about software, we're talking about humans. And that was a deliberate choice back then. And if you go to iccpp.org, my first thing was, like, is this even the website that represents the C++ community? Probably not. That represents the ISO CPP community, and it says the home of the standard of C++ on the web. That's totally legitimate. Actually, C++ it's much harder to find out where's actually the center of that universe or something like that. But that leads to problems down the line. C++ people expect things to work and expect the standardization of the standard library to work through papers and things like that. Rust takes a different approach, and those often lead to friction points. And it's important to observe this. I think both of them are okay. And particularly, it's not even hard to, it's not even easy to figure out, like, to compare these communities. For example, Rust is known for being, well, queer, kind of open, and like inclusive. On the other hand, I have to say one of the best diversity, equity, and inclusion projects, activity-wise, over the last couple of years came out of C++, which is Include C++. Like activity-wise and how it's formed as a project, there's definitely spearheading there. So we need to approach it from that direction, particularly when working, like, and C++ and Rust are going to stick around. We're in the same room. We need to take an approach of rather judgment-free and understanding. There's a lot of, well, I don't do C++ because it's all bad. It's like, oh, well, if you actually go to C++ conferences, the conversation of what C++ is in the next coming years is actually very front and center, and it's pretty interesting to be part of that, and Rust is definitely part of that conversation. It'd be good if that were actually more formal. There's currently a C++ integration initiative within the Rust Foundation, which I'm very much looking forward to what the outcomes of that will be. And I also have to say, like, going to C++ conferences in the last 2 years, the C++ community is much more welcoming to Rust than one might think. So I had some of the best conversations that I had over the last years about Rust at those places. So I think going into the future together as those two languages actually will reap a lot of benefit. So keeping that conversation channel open and finding out where those conversation channels are is really, really useful.
As always, the best approach is aloha.
So,
any
question
questions?
time.
Thank you, Til. Thank you, Florian. Does anyone have any questions? Standing close to the microphone. Yeah, we'll start here. I'll work my way back. I see you.
Okay. Thank you. I have two notes to make and two questions that I'm going to ask at once, and you decide how you answer them. So you mentioned, Adam, that cargo is the most common build system. It's more common that there is one known exception, it's Google, that uses Bazel in Android. The other one, I'm surprised that on the list of the protocols for the pub sub and things that interoperate with programs, you actually haven't put Eclipse Zeno that's written in Rust, which is an alternative to MQTT. And the questions are two. So first one is, your talk doesn't talk much about templates in C++, and that's most idiomatic code written in C++ these days, especially in companies, in financial institutions and banks. And what do you think can be made about that? It would be very hard in the current model to find a way of the interoperability if Rust is not extended in certain features that would let it be used both ways. And the other questions you started to mention, but I would like to know how you're feeling about actually Google pouring money on the Rust Foundation, on the interoperability C++. What do you think can go out of it?
Okay. I'll start quickly with an apology. I have forgotten to put Zeno on there. Thanks for mentioning it.
No, I mean, the list is certainly not exclusive, right? So, but yeah, I just didn't know about it and you forgot to add it. That's all that. Do you want to take the Google question and I can take the other one?
Oh, I can take the Google question. I think seeing like we had a lot of alternatives being shown here. I think one of the habits that Rust has is it's trying out a lot of things at a lot of places. And from my perspective, it's actually good that the Rust Foundation picks up the conversation of what is the relationship between Rust and C++ also on the technical side. So I'm very confident about that initiative. Just to be clear, I have no larger insight in how that's going to be executed. I only know the announcements just as you do. Until I see the activities, I'm very favorable to that.
Yeah, about the templates question, that's obviously a valid concern. It's a tricky one. I think we should probably separate use of templates in the implementation and use of templates in the API, because there's a lot of code out there that doesn't actually have much templates in the API, and there is much less of an issue with that stuff. But you're correct that, of course, modern C++, shall we say, heavily relies on templates, and there's also library approaches that heavily rely on templated APIs on the outside surface of that thing. And that stuff is, in fact, harder to bring over because, again, conceptual mismatches. I do think that at the language level, Rust, with its macro facilities and its ways of doing static compile time polymorphism, would enable this sort of thing. But honestly, I don't have any personal experience with bringing such APIs over, and I don't know, I have a couple of colleagues in the audience if anybody wants to comment, but I don't think as an organization we have a lot of experience with that. It is definitely a bit of an undiscovered frontier, but in practice we have a lot more code bases that use templates in the implementation rather than the API, so that's, I would say, the majority of the problem right now. Bringing over, let's say, high-end, very C++-y APIs, heavily templated APIs, I don't have a solution for that. I don't think we have best practices for that at this point, but I don't think there's anything fundamentally preventing it from working in terms of what Rust can do, because unlike the runtime polymorphism stuff, you actually have facilities in the language to enable it. I mean, Rust obviously doesn't have the same templating functionality as C++, but it has conceptually similar level facilities that would enable this. So I don't know if maybe one of my colleagues want to, Magnus, do you want to say anything on that?
At some point in the past, we tried to bring, we used the CXX crate, right? And we tried to use templates, and I think at that point it wasn't supported at all. I don't know what the current state is, but at least at that point it wasn't possible with that crate.
Yep, so fair point. That's sort of an unsolved point. Yeah. Does that answer your question?
I also want to say that the same problem exists on the Rust side. If we're exposing generics, we're basically running into the same problem. And I've seen like Swift has some interesting things around that, paying down some runtime cost at the API layer. So there's a couple of approaches nowadays that actually are like, maybe the C API is not what fits for the future, but that's futures unwritten.
Thank you. I have a question over here.
Thank you for the insightful talk. I have one point though. So we internally use this tool called AutoCXX for our project. So it was very easy to migrate existing C++ libraries. What do you think of that?
Sorry, I didn't catch the name of the tool. Something CXX?
AutoCXX. Yeah, it's based on CXX.
Okay.
Yeah.
I've not personally worked with that. I don't know. Magnus, do you know that? AutoCXX? I've not come across it, honestly. So is that another conversion thing that tries to...
Yeah, it's based on CXX, and it kind of simplifies the way we use the existing C++ libraries. So we tried internally to convert existing C++ library to Rust, and it worked. Yeah.
Okay, good. So there's something called AutoCXX. Check it out. I wasn't familiar with it. So it's apparently built on CXX. Learn something new every day. Thank you.
Any other questions? No. Then I have one for you too. When you're coming from an organization where you're adopting C++ and going to Rust, is there a certain inflection point in which it makes sense for you to start integrating Rust into your code base?
Thank you. Very good question. I think most organizations are very pragmatic when it comes to that. So there's basically three forces going on here. There's the younger developer coming in saying Rust is the shit and we should all be using it, right? They're really excited about it because it's awesome and it's fun and, aloha. But they don't get very far usually because people with suits on make decisions based on other criteria. And then at the same time, you have the regulatory pressure coming from above, where somebody in a really, really good suit is saying, look, I read this article about the NSA saying you shouldn't be using memory unsafe languages anymore, and hey, Mr. Lead of Development Department, what's our story with this, right? What are we going to do? So the poor person that leads the development department has to come up with some sort of answer for what's our memory safety story here, right? And if they're a little bit forward-thinking and they listen to their staff, they will probably come to the conclusion that maybe Rust would be a way to start addressing that. And so you have these two things sort of putting pressure on the development teams, but they still have budgets and time constraints and limited resources and so on. So what they tend to do is they look at the problem space and they go, where does Rust really give me the most bang for the buck, right? Where does it reduce my security and safety problem surface? Where do I have, problems with concurrency, where maybe I've been wanting to rewrite it anyway, and rewriting it in Rust would give me some additional benefits. So I think it should be driven, and it is actually driven in most cases, by where is the value in actually making the transition. So rewrites for the sake of rewrites happen in open source a lot, but in companies, they tend to not happen very often, unless you happen to be hidden away at some hyperscaler with a budget that everybody forgot about. Mostly people look at it and go, okay, where does it actually add value? Where do I get security benefits, concurrency benefits, safety benefits, productivity benefits if they are to be had, and where is the juice worth the squeeze? And I think that should be driving the decision making.
Thank you so much, Florian and Til, for your talk.
Thanks, everybody.
Thank you for questions.